Hi everyone. In this video, we'll be talking about multi-query streams. So we'll be talking about what are multi-query streams, why do we need them, how can we create multi-query streaming application, and we'll also see a demo. And that demo will be using Spark Scala code, and I'm going to use RAID source, Kafka sync, and console sync. So we have two syncs here. We will create two queries which will write data to two syncs, and that is why we call it multi-query streams. So if you want to understand all of these concepts, please stay with me and watch the video till the end. Okay, the first question is what are multi-query streams? So let's understand it with an example. So let's assume we have a Kafka source and we have sensor data that is being stored in this Kafka source. We have a Spark streaming application that is continuously reading from this Kafka source, and we have certain tasks to perform on that data. So our first task is aggregate by device ID, generate the count per 5 minutes, and you can write that data to either disk or the console based on the given requirement. So this is your task number 1. Alright. Now the same set of data that we are reading from this Kafka source can be used for another task, which is task number 2. Now our task 2 will be we want to filter the data based on the given location. So this can be our second task, and let's say we want to write this data to a particular Kafka topic. In this case, we have one stream and this is our second stream. From the same source, whatever we are reading, we can generate two different streams. So you can imagine like this is your input and then you are splitting it to do two different output streams. So this can be called as a multi-query stream because you have more than one stream that is being operated on the input data. Now the second question is why do we need them? So as I explained with this example, the second question is almost clear, right? So why do we need them? Because let's say we are reading from the same data source and we want to do multiple operations on that data. So we do not want to create two different Spark streaming application. We can create one Spark streaming application, and whatever data we are reading, we can perform certain transformations and create separate streams that can perform different tasks. One can write to someone at one particular destination, and the other one can be used for writing to another destination. So this is the use for multi-query streams. Now third question is how can we create multi-query streaming application? So in Spark streaming it is very simple. Let's say you are reading from a Kafka source and you are creating a data frame. Using this data frame, you can use the write stream method, write some logic, and using this data frame, again you can do a write stream method, and you can do whatever you want. Whatever queries you have created, you can start all of them together using spark.streams.await any termination. So there is a function from the Spark session. We will see that in a while. So whatever number of queries you want to create on the original streaming data frame, you can create, and you can start all of those streams at once. So I hope this is very easy to create because Spark streaming has provided a lot of abstractions. So user don't need to worry about writing a lot of code. Only they need to write stream function, and using certain options, they can easily create multi-query applications. Now it's the time for demo. So we will see an example using the Spark Scala code. So what we will be doing is we will be reading from the RAID source. Now RAID source, if you remember, it generates certain records per second. If you don't know about it, you can see my previous videos. Then you can come back to this video. So we will use the RAID source because it is very good mimic for the Kafka input, and since it generates certain number of records per second, we can tune it according to our need, and whatever data we are reading from here, we will do some manipulation and we will create two separate streams. One we will try to write to Kafka sync, and one will try to write to console sync. So console sync will be visible in the console in the IntelliJ IDE itself, and the Kafka sync I will show you using the Kafka console consumer. All right, so let's start. So this is the code for multi-query streaming application. So let us go through the lines one by one. So first of all, I'm creating a Spark session. So then I'm giving some of the variables, creating some of the variables for my Kafka configuration. So bootstrap server is localhost colon 9092. The topic is multi-query streams. So whatever the topic name I've given here, I'll be writing the data to this particular topic. Then what are we creating? We are creating a data frame. We are creating a streaming data frame because this is a read stream method and this is a rate source. And what we are trying to do is we are creating one record per second. Then we have imported spark session.implicits. Again, if you don't know about it, I have explained this in another video, so you can have a look at that. We are trying to print the schema here so that we can understand whatever data frame we have created, what exactly is the schema for this data frame. What we will do is, as I explained, you can have more than one transformations and you can create multi-query streams. Now we have this data frame right with us, the original streaming data frame. We have two operations here. One, whatever data is coming in, we have a column called value. What we are trying to do is we are introducing a new column called double value in that data frame, and the particular value will be the original value into 2 multiplied by 2. So let's say the value is 2, so the double value will be 4. So what we are trying to do is we are selecting the value and the double value. There is an additional column which is called timestamp. I will show you when I will run this application. So when it will print the schema, there are two columns for this data frame. One is value and one is timestamp. So we are going to ignore the timestamp. We are just selecting the value and the double value, whatever we have created here. And we want to write this particular streaming data frame to console. Also, we have given trigger.processing time of 3 seconds, which means after outputting the data to the sink, it will wait for 3 seconds for reading the next batch of data. Also, we have given the truncate as false so that it does not truncate the output in the console. Output mode.append I have already explained in my previous videos. So whatever data we are reading, it will be just continuing to append the output to the console. So what we're trying to do is we are trying to write to console. This is our first stream. So value and double value will be written to the console output. Now we have the second stream also. So in this, what we're trying to do is whatever value we had in the original streaming data frame, we are creating a triple value, which is nothing but multiplied by 3, the value multiplied by 3. And then for writing to Kafka, we are just casting the key and value, because for Kafka we need a key and a value. So the key will be the value and the value will be the triple value. So let's assume the value is 3, then our triple value is 3 into 3, which is 9. So what we are trying to do is we are writing the value and the triple value as key and value. So don't get confused here. Key means it is used for Kafka because Kafka needs to have a key column and also a value column. That is why I have mentioned select expression cast value string as key and as value. Alright. So again, I'm trying to reiterate. This dollar value is contained in this data frame, original data frame. Alright. With the with column method, we are creating another column called triple value, which is 3 times the value. Now for Kafka, for writing to Kafka, you need two columns. One is called key and another one is called value. Now the value, this one, we are saying, okay, consider this as the key, and the triple value which we created here, we are saying consider this as the value. Alright, I hope this is clear for you now. And we are writing this stream to Kafka. We have provided certain options here, which is bootstrap server, then the topic name, checkpoint location is important, and then the output mode dot append. Java.util.uuid.random uuid is nothing but a function which generates the random uuid, and every time I run this application, I am creating a folder in the temp directory, and this will be unique every time I run this application. So there will be no problem with the checkpoint conflicts. That is why I have given slash stem slash and then this is random uuid. Finally, for starting all these streams, we can do spark session dot streams dot await any termination. So this is the statement that will start all of your streams. Simple and clear, I believe. Now this is a very simple example, but imagine you have a Spark application in production systems where you are continuously reading from a Kafka source. You want to transform the input data, and you have certain complex logic, and but finally you want to write the data, the transform data, to somewhere, and maybe more than one destination. Let's say one part you want to write to GCP storage, one you want to write to AWS storage, or maybe another one you want to send to Kafka topic. So all of those you can do in a single Spark streaming application. So you don't have to maintain three copies of the same kind of processing logic in three different applications. So one application is enough for you, and you can create n streams for that application. Although in production systems, you should take care of how many streams you are going to create for one streaming application, because more than, let's say, a certain number of streaming application will again degrade your performance. And one more important point to note here is, since this is one application and three different streams, now let's assume there is a problem with your Spark streaming application. So what will happen? In that case, all of your three streams will go down, right? So if it is very critical, generally it is recommended to create one query per application. But let's say for grade 1, not grade 0 is top tier applications. Grade 1 or grade 2 kind of streaming applications, you can create multi-query streams. So when I said grade 1 and grade 2, means it is not so critical and some kind of downtime is expected, and it is not to be worried about a lot. So I hope you should take care when to use multi-query streams and how many query can you create in one Spark streaming application. So do discuss with your architect before deploying anything in production systems. So now I am going to start this application. So as soon as I will start this application, you will see something getting printed on the console, and also I will show you the Kafka console output. So we will validate our understanding there. So let's go ahead and start this application. So the first one is the console sync, right? So console sync, the RAID source will generate the value as 0, 1, 2, 3, like that. Now the double value for 0 is 0, 1 is 2, and 2 is 4, right? This is batch number 1. So 0, 1, 2 is done. Now the next will start from 3, 4, 5. As you can see, double value is nothing but the value multiplied by 2. So whatever the RAID source is generating, our this particular stream is taking care of the console output. Alright. So where is the triple value? Triple value is going to Kafka. So this is the Kafka console output here. Now this is key and this is value. So key is nothing but, is, if you remember here, what we are saying as key, the value which is generated by the RAID source, we are calling it as the key. So it will be like 0, 1, 2, 3, 4, 5, etc. And then the triple value will be the original value multiplied by 3. So let's go ahead and see. Don't worry about the sequential order, just see that the key and the value pair, the value will be 3 times of the key. So 0 is 0, 2 into 3 is 6, 1 into 3 is 3, 3 into 3 is 9, like that. If you go here, if you go down also, it will all into 3. So one part we are sending to console and the other part we are sending to Kafka. You can take this example and extend to any kind of sync. Alright. So this is the simplest form that I wanted you to understand. And now go ahead, add some code here and try to write to multiple places. Maybe try to connect to AWS S3 and write some data there in from one query, and maybe connect to GCP from the other query and try to write it there. So try to experiment as much as you can so that your understanding is foolproof. So this is all for multi-query streams. So what we discussed? So we discussed what are multi-query streams, why do we need them, how can we create a multi-query streaming app, and we just saw a demo using Spark Scala code. In between the video, I also explained when to use multi-query streams and when not to use. So that's it for this video, guys. I hope you liked the video and you understand a little bit about multi-query streams. Hope to see you in the next video. Happy learning.